All right, hello everyone, and welcome to my talk about how you can build versus buy your network monitoring. But first, I have a disclaimer. This talk contains a lot of my opinions that I've built over the time, monitoring networks, building networks, seeing how they break, seeing how I want to know if they're going to break. So, some things I will feel are right, something you'll have other opinions on. Come find me and chat about it, because I want to learn as well. This is not me knowing everything. This is just me telling you what I know. So who am I? I'm a network engineer. I've been doing this for 10 plus years. I've worked for managed service providers doing enterprise voice and campus networks, over-the-top service providers, and more recently, hyperscale-ish cloud providers doing edge and backbone, data center closed fabrics, that sort of thing. I have a passion for software engineering. I have some formal education and a lot of time tinkering. And more recently, I've gone into the monitoring, automation, and routing security space. So, these are just topics that I find genuinely interesting. When I wrote this presentation, I was unemployed. That's not true now. But as you can see, it will have a less corporate feel to it. So let's have some fun. So let's start off with a bit of a polling exercise. Raise your hands if your organization that you work for has bought more than 50% of their monitoring software. Come on, there's a few of you that pay software licensing to vendors, come on. All right, keep your hands up, come on, this is a multi-stage exercise. Keep your hand up if you are truly satisfied with that software. Does it do okay, that basically answers my question. I don't need to do the rest of the spiel. So let me tell you a story. This is you. You've gone and spent all this time and built a thing. That thing is a shiny, brand new, let's call it a service provider network. It's serving your customers, it's providing them, awesome quality services. You've got some differentiation in the market, you're doing something cool and interesting and people are excited about it. It's just going to hum along, all good. You're all done. Until one of these guys comes along and the usual outages happen. Fiber cuts, rectifier faults, device failures, the usual. You need to then put some monitoring around the network. You need to think about what's going to fail. The most basic case is ping a router. If it doesn't respond for a couple of minutes, then it's probably on fire and you need to send someone out and fix it. That's the most basic, that's the absolute minimum requirement to monitor the state of a network. The problem with that is your customers are going to know that there's a fault before you do, because if the router's on fire, then it's probably affecting quite a few people. So the other approach is to properly instrument a network and figure out exactly what's going to fail and what symptoms will show that failure. You can take a better approach to, one, get high quality information from your monitoring system to tell you, I know exactly what's failed, rather than there's some packet loss to this device. It traverses 30 links, goes through 10 different devices. Who knows what the problem could be? You need to have a better signal to noise ratio on that one. So this leaves you two choices, buy versus build. Don't get me on the Minecraft technicalities here. Yes, you can build a pickaxe, but let's go with it for now. So to buy, you will take an off-the-shelf product, take your vendor at their word that it does what it says on the tin, do a proof of concept if you really want to be sure, and then attempt to make that product work for you. The downside here is unless you run the most boring generic network possible, it's not going to properly have that 100% product purpose fit. It might do most of what you need in a monitoring system, and it might mostly fit your network, but that's not necessarily going to be the case. When people pick a product, they tend to do, a decision process. That process could come from familiarity. Oh, I know this vendor, I know this, I can get it up and running in the shortest amount of time, because time equals money. Or they gain it through acquisition, or it's just the cheapest thing. Open source monitoring is the thing. So the easiest option is often what we see in the results of the straw poll. It doesn't quite be good enough, or it is just good enough, but it's not great. So therefore you have building as an option. You get the opportunity to instrument the network and do it in a way in which you can improve the effectiveness of your operators, reduce alert fatigue, and improve the quality of service to your customers. So while building a monitoring system with open source bits and pieces, you won't get a snazzy UI that promises to monitor all the things, nor will you get a steak dinner from the vendor when it comes around to license renewal time. But what you will ultimately get is the opportunity to pick measurements and metrics that matter to you, based on metrics that actually relate to your business, and allow you to tackle problems that are uniquely yours. Not every network is the same. So while I'm not here to bag off-the-shelf vendors, I quite like some of the products that are out there, but what I'm here to talk about is how you can use a built part of your monitoring system to potentially, coupled with an existing solution, to fill that gap, to give you a complete view of what's in your network and help you get some of those efficiencies. So I will, at the end of this, upload to my GitHub a complete network and monitoring system in a Container Lab network and a Docker Compose file that is production deployable for the most part, that exemplifies exactly what I'm demonstrating here today. I've not got it up now because I wanted to put a bit more polish on it so that it would work for anyone that wanted to try it. It's one thing to have config up on the screen and talk to it, but it's much better if I give it to you folks and you can actually dig in and see, oh yeah, that's how that works, that's how that talks to that, that's how that works. So with that, let's get started. Prometheus. So Prometheus I wouldn't call a monitoring system. It's more of a framework for building monitoring systems. It came from some ex-Googlers who wanted to replicate the rough concept of an internal Google tool called Borgmon. Now, the idea of Prometheus was to build a flexible metrics collection and storage system that could store any sort of metric at massive, massive, massive scale. Thus, you see this in cloud environments. I'll take you through the basics of how Prometheus collects metrics, what the metric format is, and how you can do some cool things within it to bring in contextual data that's important to you. So Prometheus doesn't do much without some configuration. You need to give it a configuration file, which is a list of targets, and I'll get onto what a target is in a moment, or you can define targets dynamically using a service discovery mechanism, and I'll get to that in a bit. Targets are just web interfaces, so HTTP interfaces, called exporters, that expose metric information over HTTP. It's just clear text, human readable. It's a reasonably nice format that I'll get to. Prometheus will then scrape those targets, so perform an HTTP GET against those at a regular interval. This is very fast and very efficient because it's just HTTP. And because it's stateless, it scales very well as well. Exporters are little binaries that provide a nice abstraction layer, hiding where the metric data comes from and what protocols or scripts that need to be called to collect it. And it just simplifies the interface. So the metrics that an exporter exposes will look like this. It's a reasonable size. On the left, we have the metric name, so OC interfaces in octets, and then within the curly braces, we have a label set. So anyone that's used InfluxDB in the past will know that label sets are just tag key values that are attached to a metric. Same idea here. And on the right-hand side, we have the value. Values in Prometheus can only be integers. So floating point integers, whole numbers, that's it. You can't have strings as a metric. So it's sometimes easy to map strings to numbers instead to represent it. As long as you can export metrics in this format, you can get them into Prometheus. Prometheus was originally designed to be cloud native, where each service or each microservice would act as its own exporter and export its own metrics. So providing a list of targets makes sense. You just provide the list of microservices that you want Prometheus to go and scrape, and it would go and collect in the metrics from them all. And this makes for a really flexible collection and export and storage type mechanism that sort of decouples those. So how then would this exporter pattern work for the network? The exporter would then talk your network protocol, be it SNMP or GNMI, to the network device, parse and then expose the metrics in the Prometheus format natively. It'd be really good if devices exposed this HTTP endpoint themselves. None of them currently do. Sort of. Some do, you can. There are binaries you can install, there are processes you can do. If you want to know how, come find me later. But for the most part, you've got to rely on our good old SNMP or the up-and-coming, maturing streaming telemetry through GNMI. This pattern is called the proxy pattern. You have one exporter that will proxy the metric collection from a whole bunch of network devices. You could have one instance of an exporter for each device, but then you're just wasting cycles and memory to have multiple instances when you can just do this proxy pattern instead. If you have quite a lot of devices, you can potentially use a pool of exporters that each talk to whatever device it's pushed against. Because Prometheus is talking HTTP to the exporters, stick a load balancer in the middle, put 3, 4, 5, 100 instances of the exporter behind it, and on every request that gets round robin through the load balancer, the next device will get targeted by whatever exporter in the pool. The target configuration in this case for this proxy pattern, and this is more so as a reference for anyone because I constantly find I'm Googling this, would look a bit like this. You can see at the top we've got the job. So the job is SNMP devices. We have the static configuration for the targets, the metrics path, so that's the HTTP path we're going to hit on the exporter, and then some label magic. I'll gloss over that, it's just mostly for reference. But what you end up with is the two URLs in green. So the target name is substituted as a parameter against the exporter. So the exporter will receive that, pull out the target, I need to go talk SNMP to that device, and it goes and does it for us. But Tim, you ask, what if I have hundreds or even thousands of devices that keep changing day to day? They're failing, I'm decommissioning them, I'm provisioning them. That's going to be an annoying text file to keep up to date. Surely there's a better way, even with configuration automation. No, I think we can do a lot better. Glue code and cron jobs work sometimes, but no, we can do it natively. So service discovery mechanisms are really, really useful for pulling in targets dynamically. Because we're all good network operators and we use Netbox or any other source of truth to store devices in our network, right, then why don't we have Prometheus natively talk to Netbox and pull out the list of targets for each job? Just like everything else in the Prometheus land, it's all over HTTP. Prometheus can, on an interval, run an HTTP GET against Netbox and pull out the target information, and it comes back in a nice JSON format. There's a Netbox plugin in the community that works really, really well to do this. You just run a GET against the plugin URL with your filter on the end of it. So I don't know if anyone's used the Netbox API, but you can say, I want devices that are in the status of active by this manufacturer that are in this location, and it will just return that for you. And it's really nice because if you just set a device to active in Netbox, it'll just appear in monitoring. You don't have to wait for the daily discover job. You don't have to add it manually, God forbid. But what you also get with the service discovery is additional labels that'll be added to every metric from that device. So that might be a little tricky to read, but these are all the device-centric parameters that you'd see in Netbox. Site, manufacturer, device model, status, location, rack, RU, everything can be included on the metrics. So suddenly you've already got some enrichment going on. You say, oh, I want to know the average interface utilization for this model of router for this site. It's all there ready to go, and it's all contextualized for your network. And this then is the configuration for the service discovery. We just make a query for the active devices, so in the purple section, and every 15 minutes it'll run that and update the target list. It's really quite neat. So now we have targets, exporters, and exposed metrics. Prometheus is just a single binary, so it collects these metrics and stores them to disk in an indexed blocked chunks on disk in its own internal format. Everything else is done through the API, including the web interface that Prometheus exposes. Alert Manager is another component. It basically runs queries periodically, and it will then trigger on expressions you give it. So when this router gets too hot or when that link gets too full, it can query it and tell you everything. So how then do we go about using this framework to build a monitoring system that actually gives us insights that we care about? let's start off with a few example questions that we might want to use to sort of drive that process. What is my global uptime for Ethernet customers based on link state? Now, this is a useful insight question because it can be linked directly to the SLAs you're promising customers, as well as the service assurance you're getting from your layer 2 access vendor. How good is their service? And second, what percentile am I running my upstream transit circuits at? This is useful because you're paying the bills for transit. No one likes to pay overages if they're not expecting it. So it would be good to know, last month we ran them up to 78 and now they're approaching 85. I could be up for some overages unless I perform some action here. So let's use these questions to start thinking about what metrics we should collect and then how we should enrich them with contextual data to help us answer these. So we want to merge metrics like this, so this is streaming telemetry, with useful contextual data like customer records, network service records, and device metadata, if you're not using the Netbox auto service discovery. We want to use that to produce some pretty dashboards. This is an example I built for EdgeIX, where I grabbed the customer data and I matched that with the metrics data that we're collecting out of the PEs, and I just have a lovely customers drop-down box. I don't have to parse interface descriptions. If the customer record changes in the BSS system, then these will update as well. It's really, really nice. I can just go and click down and show me any customer record that I like. So I can show exactly what each customer is doing. I don't have to go and figure out, this customer has an interface there and an interface there. It's too hard. It's all just done. So because we can export anything as a metric, why don't we have a small binary, an exporter, that connects to your BSS via API and exports your customer records and their network services. You'll see here we've got record for 3 fictitious customers. We've got the customer name, we've got the router that their service is on, the interface that we're using for them, and a circuit type. I just called it CID as any label. But this fictitious service provider serves 1 gig and 10 gig customers. The metric on these is all 1. Take note of that, we'll come back to that later. So from our exporters, we can be collecting OpenConfig streaming telemetry data at the top and SNMP data from the bottom. So you can see the labels are slightly different because those labels come in from the exporters. They're different exporters, they're going to be different labels. We'll deal with this in a moment. So Prometheus happens to come with a web UI built into the binary. It's really quite nice, it's pretty useful, but at least it comes with a dark mode too, and it fits the rest of my presentation. So what we've got here is the streaming telemetry data. It's a counter, it goes up and to the right. Just believe me on that one, I know it's a bit flat, it's from the example network. But here, this UI is really, really useful for testing queries and just debugging metric issues in general. I just wanted to point that out. This is a really nice inclusion. So, we want to marry the OpenConfig streaming data with our customer data. How do we do this? So in Prometheus, there is a recording rule. It's effectively a query that runs on an interval and writes to a new metric. What we can do is what's called a vector match operation. Think of it like an SQL join, except it's a vector operation, so it affects the metric as well. It's not just joining columns, you're looking at the labels and joining the metrics together. And the join is done based on label match criteria. So a group left, which is the parameter in the query, which I'll show you in a second, will look at the labels on the left-hand side of the metric, so this is the OpenConfig streaming telemetry data, and marry it with certain labels on the right, which is our customer data. So with this information, we have some mismatching labels. We can fix those up with a little bit of magic. You can, in Prometheus, in the configuration, you can do label mappings like we were doing for the exporters. We can just make them all the same. So now the streaming telemetry metric router and interface labels, because they're the ones we care about, match with the customer data. So now we can make a recording rule to bring these together. We're using this opportunity as well to convert the counter into a rate and then multiplying that rate by 8 to turn octets into bits. So the key part here is, rate metric name times 8, and then multiplied by, so star, on router interface, which are the two labels we want to match against. Group left, bring in the customer and CID records from the service metric. So as long as we've got the exporter bringing in the customer records every so often, 5, 10, 20 minutes, that's fine. And then every 15 seconds, in this case with the open config data, it will match them together based on those labels and stitch them into a new metric. If the port on the router is changed to a different customer, the service record in the BSS will get updated and the metric will then be sewn together with a new customer. So you don't have to try and marry up in time, it will just be stitched into a new metric. So really useful to see, that port was used by that customer, now it's used by that customer. So remember how the customer metrics have a metric value of 1. When we do the multiplication here, anything multiplied by 1 is itself, so we end up getting the same metric. And ta-da, we end up with this as the result. We've got metrics that are interface rates, all enriched with our customer information. We can see how many ports a given customer has. We can see their total bit rate by summing them together. We can average them. We can count their bits for billing. We can do all of that. We don't have to parse interface descriptions or have to manually generate a report and pull it all together. It's all just in the metrics. So now you've got a really nice native experience to be able to explore your customer services. And we can do the same thing with the SNMP data. Yes, the label matching and the label reconfiguration might be a bit different, but you can still export that to the same metric name. Now we have a metric called port bitrate that comes from SNMP and streaming telemetry, it doesn't matter, with the same labels updated by customer. So now it doesn't matter if you've got an old device and a new device, you can still do streaming telemetry and it all comes out the same, and you can still build the same visual dashboards that are useful for the NOC and billing and anyone to do the same, irrelevant of the metric collection technology. That's not really the end of what's possible either. This was just the smallest example that I could throw into 25 minutes. If you're not using Netbox for the service discovery, build a Netbox exporter. Maybe you want to export circuit information, transit circuits and peering circuits and PNIs. Those have a router and those have an interface. So we could also, if these match to circuits that we pay for, I could now be looking through my metrics for, show me all my transit circuits, show me the average utilization for my transit circuits, show me all my Telstra circuits, or whichever provider you happen to use. If you have an OSS for, say, GPON, you could be updating your metrics based on the OLU or ONU or OLT device type. So you could look at, average environmental temperature by OLU, OLT. And I've mentioned the point about circuits. That one I think is probably the most useful for folks. Really, anything's possible as long as you can pull the metrics out that will make it useful for you to ask and answer some of the insight questions we talked about at the top. Now, if you're not following along, that's fine. I'll publish the full working demo and I'll put it in Beer for Peer Slack and I'll drop it on the mailing list if people want to check it out. I'll provide some documentation with it and hopefully make your life a little easier to understand this concept, if you really want to dig into it, of course. I've not even touched on alerting enrichment or customer-centric dashboards or service diagnostic dashboards. That all becomes possible when you've got the right information matched with the right metrics to be able to dig through and ask and answer questions. So, having done this myself, I have a bit of advice. If you're going to write an exporter for your OSS or BSS to bring this information in, add some caching. Because if that platform goes down, it needs to be rebooted or it ran out of disk space, your exporter's not going to work and you're going to have a gap in your metrics. So have that exporter binary on failure to the source, just cache that information for an hour or two. It'll save you, having issues. And when writing your exporter, use that opportunity to define your metrics. The OpenConfig metrics come out with interface_name and source. I prefer interface and router. So I made that in my customer exporter, and then just used Prometheus label rewrite rules to match them up. And as we did here, work backwards from the things you care about or the questions you have to the metrics you want to produce, because they're going to be much more useful to you than just a pile of data that you don't know what to do with. Start with a question. Start with something that you're interested in, start with something your customers are asking for or your NOC is asking for, and work backwards from there. I'd just like to say a few thank yous. Firstly to Joe IX, and Joe at Edge IX. He's given me the opportunity to muck around and produce the metrics for that, so I've learned a lot in doing that. Roman and Karim work on the Container Lab project, which my colleague will talk about tomorrow. Check out Container Lab, it's an awesome piece of kit. The sample network for this is all built in Container Lab as well. And lastly, Brody for my meme consultant. And lastly, where to find me. LinkedIn, I happen to be on the Bird site, don't know how long that's going to be. True for the Beer for Peer Slack and the Netbox dev community, where there's a lot of really interesting people building some really awesome plugins. And email is also easiest as well if you want to reach out. Thank you so much for listening.
Do we have any questions for Tim?
Nothing.
You must have done a very good job then. Awesome. Oh.
Jacob is impatiently asking when I'm going to put up the GitHub repo. Let's say by end of next week. I've said it now, I'm going to have to do it.